In this tutorial, I will explain how to know from the curve, the shape of the curve, the titrant, the analyte, the pH at equivalence, and in case of a weak substance titrated, how to determine its pKa or its pKb. So let's first look at this titration curve. First, this titration curve starts from up and decreases. So we are titrating a base with acid. So we are titrating a base with an acid. Also, if you look at the x-axis of the curve, it is showing volume of HCl, which is an acid added. But some graphs, they don't write. So if it's not written, you just see from where the graph is starting. So here, the analyte is a base and the titrant is an acid. Always at the x-axis, they will put the titrant. But in case it is not written, you will have to figure it out the way I am explaining it. Now, the second thing, are we dealing with a weak base or we're dealing with a strong base? Looking at this start, it starts from 12. Not really telling, but I can know that to be a strong base, it has to start from above. Now, let's just be sure of it. Is there a slight drop? Yes, there is a slight drop in this curve. Next, is the pH at equivalence 7 or not 7? Or below or above 7? So here, the equivalence point, it looks that the pH at equivalence point is not 7. Then definitely we are dealing with a weak base, titrating it with a strong acid. So here we are titrating a weak base with a strong acid. So what we did, I looked how the curve is starting. Is there is a slight drop or it's decreasing like almost a horizontal line? It could be like this if it's a strong base. And is the pH at equivalence equal 7 or not equal to 7? So here the pH was less than 7, meaning that I am titrating a weak base. Now in these kind of questions, okay, let me just answer this question. pH at equivalence here is equal to 6, and the volume at equivalence is equal to the volumes at equivalence point is equal to 50 milliliter. Now always expect in the titration of weak with strong to ask you to find the pKa or pKb. Now you have to pay attention that the curve will always give you the pKa, not the pKb. So the pKa can be determined from the curve, not the pKb. But we can always find the pKb if we have the value of pKa. And how do we get the pKa? At half equivalence point, pKa is equal to pH at half equivalence point. And this curve is showing us the pH. So we can determine half equivalence point. So if equivalence point is 50, then half equivalence point is 25. And we get the pH at this point, which is going to be equal to the pKa. So this one is almost 10.5 or 10.7. Let's say almost over here. If here is 11, then this is maybe 10.8 or 10.9. So let's say that here it is 10.8. Okay, so pKa in this one is 10.8. How do I calculate the pKb? Note that pKa plus pKb is always equal to 14. So if you want to calculate the pKb, you are going to say 14 minus the pKa that you just found. And that is equal to 3.2. Let's look at another curve. This curve starts from below. So we are titrating an acid with a strong base. Now, what is the nature of this acid? Is it strong or is it a weak acid? Look at the start. It starts from above 2 and there's a jump at the beginning. So we are dealing with a weak acid. We are dealing with a weak acid. So the analyte is a weak acid and the titrant is a strong base. Now next, what is the pH at equivalence? The equivalence point shows almost here. It's slightly before 20 milliliter. And the pH at this equivalence point is almost equal to 9. So pH at equivalence is equal to 9. And the volume at equivalence point, let's say that this is maybe taking it like 19 milliliter. Now, in order to determine the pH, the pKa of this weak acid, we take half of this 19 milliliter, the half of the equivalence volume, which is almost 9.5. So it's going to be slightly here. And looking at it, at this point, pH equal pKa. So we are looking at 4.5 probably. So at half equivalence point, when the pH, when the volume is 9.5 milliliter, at that stage pH equal pKa, and according to the graph it is equal to maybe 4.5. Now let's take the last example. Looking at this graph, here we have a pH starting from up. We have a pH starting from up and decreasing. So we are titrating a base with an acid. A base with a strong acid. Now, how is the curve starting? Is there a slight drop or it's going almost a straight line? Is it starting from above 12 or below 12? Is the pH at equivalence equal to 7 or not equal to 7? All the indications here are showing that we have a strong base, and specifically because the pH at equivalence is equal to 7. In a case of a strong, we will not look for half equivalence point and pKa or pKb because we will not have a buffer solution at half equivalence point.